We're going to do the Unit 4 sample work assignment, Unit 4 vocabulary. I'm going to go lesson by lesson. So Unit 4, Lesson 1, keywords. You'll find it on the second slide here. List the objectives, identify the relationships between figures in space, identify angles formed by two lines in a transversal. So here we go, keywords, and there's a few of them here. I'm going to not do them in alphabetical order because there's an order that makes a little bit more sense. Parallel lines. Parallel lines. And let's clean that up. Sometimes my handwriting is good, sometimes it's lacking. Okay. Parallel or parallel lines. It's lines in the same plane. Plane, A-N-E, that do not cross. Okay, example, two lines on a flat sheet of paper that never cross. As opposed to parallel planes. Parallel planes are simply planes that do not cross. Remember, a plane is kind of like a 2D line. It has no boundaries. So it's limitless, endless. Okay, like the floor and the ceiling in your house. Only the floor and the ceiling have boundaries. So I'm going to draw two parallelograms kind of separated by some space. Think of the floor and the ceiling of your house or of the room you're in, with the exception that planes don't have any edges, right? But those would be parallel planes, planes that do not cross. Okay. All right, so skew lines. Skew lines. Skew lines are not parallel, but still do not cross. Well, you might ask, how can that be? Do not cross. Not parallel, but do not cross. Well, an example would be a freeway overpass. What I'm going to do for this example is I'm going to draw a three-dimensional cube. Okay, and I'm going to highlight two of the edges. So this bottom edge we'll call line L, and this top edge that we'll call line M. Because M passes over the top of L, M and L never cross, but they're also not parallel, so they are skew. Transversal. Transversal. A crossing line. A line that crosses two or more others. A crossing line is a transversal. So we have two lines, and by the way, the two lines do not need to be parallel to have a transversal. Okay? They just need to be crossed by a third line. The line that crosses two lines is a transversal. Okay? All right. Now we need to identify the pairs of angles. Corresponding angles. Okay, corresponding angles are on the same side, different, same side, different intersections. Like, I'm going to number them, angles 1 and 2, which are both on the top right. Angle 1 and angle 2 are corresponding. Okay, same side, different intersections. Top right, corresponding. Alternate interior. alternate interior. Two words, alternate and interior. So they're on opposite sides of the transversal. Okay, and inside the crossed lines. Inside the lines that are crossed, which may or may not be parallel. So 1 and 3 are alternate interior. Actually, sorry, bad. 1's not an interior angle. 2 and 3. Angle 2 and angle 3, the way I've numbered them, are alternate interior. Okay? Alternate interior. Alternate exterior. Alternate exterior. They're on opposite sides of the transversal again, but they're outside the crossed lines. Okay, if I add a number here, angles 1 and 4 here are alternate exterior. Angle 1 and angle 4 are alternate exterior angles. They're outside the crossed lines, outside, and they're on opposite sides of the transversal. One's on the right, one's on the left. Alternate exterior. Okay, that brings us to same side interior. They're on the same side of the transversal, as opposed to the alternate or opposite sides of the transversal. And they are inside the crossed lines. Okay? So if I were to name all same side interior angles, I'm going to number at angle 5 right here. So angles 2 and 5 are same side interior angles. SSI angles, same side interior. Okay, let's see, have we got them all? Corresponding parallel planes. Yep, that's it for this lesson. All right, so let's go back to our course outline here and go to lesson 2, properties of parallel lines. See if there were any words there. Yeah. Alternate exterior, we've already defined, and you don't need to define a word twice if it appears twice. Alternate interior, we have already defined. Corresponding, we've already defined. Parallel lines, we've already defined. Same side interior, we've already defined. Transversal, we've already defined. So we don't need to do those again. Lesson 3, alternate exterior, alternate interior, converse. Okay. Yeah, I'm going to go ahead and define it. We've defined converse in a previous chapter. And that's why I debate about including it here. Converse, switch the if and then parts of a conditional. Okay? So for example, if it's parallel, then corresponding angles are congruent. The converse of that would be if it's congruent, if the corresponding angles are congruent, then the lines are parallel, where we switch the if and then parts. Converse. And that comes up in this unit because the corresponding angle postulate says if angles are, or if lines are parallel, then angles are congruent. We need to be able to prove lines parallel and use the converse of the corresponding angle postulate, which says if corresponding angles are congruent, then the lines are parallel. All right, corresponding angles, we've already got flow proof, and same side interior angles we've got, but flow proof is new. So a flow proof, also called a flowchart proof. Okay, that's where reasons or statements are in boxes, and reasons are given below the boxes. Okay, here's an example. Okay, I'll prove vertical angles. So we're given these two angles, 1, 2, and 3. Okay, so 1 and 2, measure angle 1 plus the measure of angle 2 is 180. And the reason is linear pairs are supplementary. So it's called the linear pair postulate. Okay, and I might also say the measure of angle 2 plus the measure of angle 3 is also 180 for the same reason. And I'm not going to do the whole proof, but I would use arrows now to indicate those two combined say that measure angle 1 plus the measure of angle 2 equals the measure of angle 2 plus the measure of angle 3. This is a proof that we did on a previous quiz. And the reason is the transitive property. So that's a flowchart proof. Statements in boxes, reasons below the boxes, arrows indicating what direction you go. Okay. All right, that's it for lesson 3. Lesson 4, parallel and perpendicular lines, no new words. Lesson 5, lines and triangles. Auxiliary line, exterior angle of a polygon, remote interior angles. Okay? And we're going to prove a theorem about triangles, find the measures of angles and triangles. Okay, so auxiliary line, exterior angle of a polygon, and remote interior angles. Okay, so let's go to a new slide because we've filled this one up. Okay, auxiliary line. Okay, an auxiliary line is an extra line drawn just to help in a proof. Okay, so for example, the theorem that says the angles of a triangle add to 180. Okay, you can start with a triangle, right? A, B, and C. But what's more important is you can draw a line through C so that it's parallel to A and B, right? And that's an auxiliary line. And by the way, that helps us prove it because alternate interior angles, say 1 and 2, are congruent. So I'm just going to go label these 1 and 1. And alternate interior angles also says this angle is congruent, so 2 and 2. And 3. And we know that the angles that form the straight angle are 180. So angles 1, 2, and 3 by alternate interior angle theorem and by the supplementary angle, definition of supplementary angles, or, well, yeah, the linear pair postulate, if you like. It's a little more complicated than that, but they add to 180. Auxiliary line. Okay, exterior angle of a polygon. Exterior angle of a polygon. Okay, it's formed, the angle is formed by extending a side. So the example given in this unit, and the reason it was brought up, is if you have a triangle and you extend one of the sides, you form an exterior angle. Okay. And then remote interior angles. remote interior angles. Okay. Angles inside, but opposite an exterior angle. Okay. In this case, if angle 1 is the exterior angle, angles 2 and 3 are the remote interior angles. Remote interior to angle 1. Okay, remote interior angles. Okay, so let's go on. Lesson 6, constructing. See if there's any vocabulary words. Here we go. There are some words here. Keywords. Equilateral triangle. Okay, 3 sides, all congruent. So an equilateral triangle is a triangle where all 3 sides are congruent. Polygon doesn't mean your parrot is lost. Polly's gone. Oh no. Polygon. Polygon is a straight-sided closed 2D shape. Okay, as long as the sides are straight and it's closed, that's a polygon. Quadrilateral. Four-sided polygon. So any straight four-sided shape. So 4 sides, closed, straight sides. Okay, regular hexagon. It's a polygon with 6 sides. All angles and sides are congruent. Regular hexagon looks kind of like this, in which all 6 sides are the same length, all 6 angles are the same measure. Angles and sides are congruent in a regular polygon. And final word here in this lesson, square. I'm going to define it as a regular quadrilateral. Regular meaning equal sides and equal angles. You can also define it as a polygon, a quadrilateral with 4 congruent sides and 4 right angles. But all the angles are 90 and all 4 sides are congruent in a square. Okay, and that's lesson 6. Lesson 7 on constructions. Doesn't look like there's any new words. Yep, no new words. Lesson 8 is a unit review, so there's no new words. So that concludes our sample work.